This demo will show an example development session using the A2F Linux environment. This session was performed on a pre-configured Fedora 14 Linux VMware machine running on Windows. This machine has been preloaded with the software images that customers who purchase the A2F Linux product will have. Those images are shown here in this directory. The A2F Linux 1.1.0.tar.bz2 is the A2F Linux development tree. The ARM 2010 files there are the CodeSorcery compiler packages. The install.sh script is something we wrote just to extract these packages, and I'll invoke that now. This video is about 10 minutes, but it's unedited and it shows the full development without cuts, so there'll be some quiet periods. Starting up another console, let's telnet to the A2F Dev Kit board. This is the board that was loaded with UC Linux in some of the earlier videos. In this demo, we'll be logging in through the network instead of using the serial console interface. Both are obviously usable if you need to. Checking the IP address of this VMware machine, we see that it's on the same subnet, 192.168.1.34 is the assigned IP address. We'll remember that when we're continuing with the demo. Okay, the package is installed. An A2F Linux 1.1.0 directory is created. To set up the environment, you source the activate.sh script. This sets up environment variables. You can see I've navigated down into a projects directory, and I'm looking at the configuration files. The BusyBox configuration file is used to configure the BusyBox program. The init ramfs file is used as kind of a shopping cart of pulling all the pieces together to create the init ramfs file. And then, of course, the kernel config file is the well-known Linux kernel config. The local directory contains some of the files, for instance, that go into the etc directory on the init ramfs. And the app directory is a dynamically loadable driver sample. I've initiated a make all, and this will go through and build BusyBox. It'll build the kernel. It'll pull together an init ramfs file after it has built the app and pulled together the files from the local file system. This will take just a bit, so let's go ahead and on the telnetted connection to the A2F Dev Kit board, we're going to NFS mount a root file system from, or actually just a file system directory from this Linux machine. Before I can do that, however, I need to make sure that I start up that NFS service on the server. Start up NFS services and export the file system. And just to make sure the ports file is allowing 192.168.1.100, which is the A2F Dev Kit board from the previous example, to NFS mount the directory. It seems we have two files in this directory from previous development sessions. The mount is successful, and I list that NFS mount point, and I see the two files. Using NFS is a very simple and convenient way to do your development work with the A2F Dev Kit. We'll let the build finish. From Linux, use the flash erase all to erase the flash partition that is used to store the Linux image that was previously installed in one of the earlier videos. You'll see it's the MTD1 partition. Once the build is complete, we'll copy the new .u image over to the board and copy it to flash and reboot. Okay, the build is complete. We'll use FTP to move the image to the board. FTP is a service that wasn't demonstrated in the earlier video, but it is available. Make sure you set binary mode and put the .u image to the board. On the A2F DevKit Linux, use DD to copy that new image to the flash. While that's happening, let's go ahead and run the make bmenuconfig. Looks like I need to make my window a little larger. It's a graphical configuration. Bmenuconfig will allow us to configure the BusyBox. And as an example, let's increase the functionality of BusyBox by adding the tar applet. But let's go back to the flash copy. That seems to have finished. We'll reboot. Wait for it to come boot back up and then try to log back in. All right, back to BusyBox. Let's add tar capability. You can see as you navigate, there's lots of functionality the BusyBox provides that can be added. And once you've edited the exited the configurator, do a make call. And we'll see if our new Linux has booted, which it has. And we're back up and running. And you'll see that the tar functionality is not included in the BusyBox. It's linked into that init RAM FS on that board. And so let's take the new BusyBox that we just built and let's copy that to our NFS mounted partition, and we'll run it on the board to verify that tar does come up and work. So we'll go to the BusyBox build directory and we'll copy the BusyBox binary to the root file system that's NFS mounted. And then back on the board, and I can tell you this isn't going to work because we haven't NFS mounted re-NFS mounted after the reboot. So let's go ahead and mount that again. And there you are. tar running on UC Linux. Pretty simple to do. Okay, let's go back and show an example of installing a dynamic Linux kernel driver. And this is that app directory, and as part of the make call, the sample.ko is created. I've just copied that to the NFS mounted partition. And I'm back on the A2F dev kit. I'm using insmod to install it. And you'll see that with lsmod, that's drivers loaded and ready to go.